Yeah, Prakriti, let's start our snap on networks.
Okay.
What is an active element?
Yes, sir. Active element.
Yes.
Sir, it supplies power to the network.
Okay. So if that is the case, a capacitor also can supply power.
For a certain period, capacitor also supply power to the network. तो it locally उसको हम active बोलते हैं, locally active, क्योंकि first वो charge होगा and then जब वो power discharge करेगा उस time पे वो as a active source behave करेगा.
Okay. What is a dependent source? Can you explain about dependent source?
सर डिपेंडेंट सोर्सेज वो किसी भी इंडिपेंडेंट सोर्सेज पे डिपेंड करते हैं. उन जो भी उनकी एनर्जी होती है वो किसी पर्टिकुलर इंडिपेंडेंट सोर्सेज पे वो डिपेंड करके अपना एनर्जी स्टोर करते हैं एंड देन उसको डिसिपेट करते हैं.
So the dependent source is going to depend upon independent source, or it is going to its value is going to depend upon some other variable in the network.
Dependent sources values depends on independent sources.
Okay. What is the significance of RMS value?
सर आरएमएस वैल्यू जो है किसी भी जो भी इन एसी सर्किट्स जो हीट डिसिपेट होता है वो आरएमएस वैल्यू, अगर हम आरएमएस वैल्यू पे कैलकुलेट करते हैं तो जो उसका हीट डिसिपेशन होता है वो डीसी वैल्यू के इक्विवेलेंट होता है. मतलब कौन एक्चुअल उसका हीट डिसिपेशन होता है, इसीलिए हम आरएमएस वैल्यूज को कंसिडर करते हैं एज कंपेयर टू एवरेज और मैक्सिमम पीक वैल्यू.
So what is the difference between a circuit and network?
सर एक अगर कोई क्लोज पाथ, अगर कोई नेटवर्क है अगर वो क्लोज पाथ बना रहा है तो वो हमारा सर्किट हो गया. और जैसे सर अगर हम एक एग्जांपल के तौर पे देखें तो हमारा पावर सिस्टम जो है वो एक नेटवर्क है, लेकिन अगर हम पावर सिस्टम के अंदर जो हमारा एक इंडक्शन मोटर वर्क कर रहा है क्लोज पाथ में तो वो एक सर्किट हुआ.
Okay, fine. Take one circuit. Take one circuit.
यस सर.
Take one voltage source.
1 voltage source. यस सर.
In series with resistance R1.
ओके सर.
Shunt resistance R2.
यस सर.
One more resistance R3 from the second node extension.
Second node.
Yeah. See, after voltage source, we have one node, right? Voltage source, series with
Yes.
resistance R1. That ending node is there. From there, you extend horizontally, not vertically, horizontally, R3.
Okay, sir.
Close that circuit with R4.
Okay, sir.
Now, if I provide you the values of R1, R2, R3, R4, and voltage source value, I want to find the currents that are flowing in that circuit. How many equations are needed?
Current find करना है.
Yes.
Sir, 2 equations.
Okay. How many loops we have in that circuit?
Sir, we have 3 loops.
So how many loop equations I have to write?
Sir, we have to write 2 loop equations.
What are those 2 loop equations? Can you tell?
Yes, sir. Sir, if we assume current I1 in loop 1 and I2 in loop 2, then first loop equation is V minus I1 R1 minus I1 minus I2 into R2 equals to 0.
Okay.
And the second loop equation is minus I2 minus R1 minus I2 minus I1 into R2 minus I2 into R3 minus I2 into R4 equals to 0.
Okay. Third loop equation we are going to get one third loop equation, right? Overall loop. Is that
Yes,
equation is useful or not useful for us?
That equation is not useful for us in this network.
Okay. Fine. Yeah. Can you explain star to delta conversion?
Star to delta conversion.
Yes. I have 3R ohms in delta connection. 3R in delta connection.
Okay, sir.
Convert into star and tell me how much you are going to get in star connection.
Sir, in star connection, we get R values, R, and R.
R. Okay. What is the basis for the star to delta, delta to star conversion? What we have to keep in mind when we're converting from delta to star or star to delta? If a star connected network is absorbing 10 watts of power,
Yes, sir.
if I convert that into delta,
Convert. Okay, sir.
yeah, how much it will absorb?
Sir, if we converted that star connection into delta connection, that it will absorb 10 watt power.
Okay.
But if we reconstruct into star into delta, then it will absorb 30 watt.
Okay. Is it exactly 30 watt or will be some change from 10 watt?
Sir, exactly 3 times.
Exactly 3 times. Okay. Fine. So for some circuits, Thevenin's equivalent will not exist.
Yes, sir.
We can't find VTH. For some circuits, we can't find RTH. Okay. Can you give some examples of those circuits?
We can't find a VTH, sir.
Is it
For,
applicable? See, Thevenin's is applicable for nonlinear networks.
no, sir. It is not
For
applicable.
all nonlinear networks, we can't apply. We can't get VTH and RTH.
Yes, sir. Yes, sir.
Okay, fine. Then Thevenin's is not applicable for nonlinear networks, but we are using Thevenin's theorem for finding RTH and ZTH in analog electronics. All analog devices, the devices which are using all analog circuits using BJTs, diodes, operational amplifiers are nonlinear, but we are using Thevenin's. Can you explain how we are using Thevenin's there if Thevenin's is not applicable for nonlinear networks?
Sir, we are calculating RTH values there, no, sir.
Yeah.
सर रेजिस्टेंस इक्विवेलेंट रेजिस्टेंस सर वहाँ जो भी एक्टिव सोर्सेज होंगे उनको शॉर्ट करके तो निकाला जा सकता है बट
So you mean to say if there is a diode,
इनपुट थेवेनिन
you're going to short the diode. Why you are shorting the diode?
सर नॉन लीनियर नेटवर्क भी सर एक सर्टेन अगर हम उसको कुछ सर्टेन मतलब लीनियर में कन्वर्ट कर सकते हैं सर्टेन ड्यूरेशंस के लिए डायोड को भी सर कुछ सर्टेन टाइम के लिए डायोड भी एज अ लीनियर मतलब शॉर्ट अमाउंट ऑफ टाइम के लिए
So that
उसको
linearity is called as what? That linearity is called as what?
सर उसका नाम याद नहीं आ रहा है मुझे
Okay, fine. Then what is the time constant of a series RC network?
RC network sir
Yeah, series
sir
RC.
series RC it is RC sir
Okay.
RC.
I want to reduce the time constant of series RC network. Can you give the possibility? How can I reduce the time constant of series RC network?
सर टाइम कांस्टेंट रिड्यूस करने के लिए सर अगर हम इम्पल्स वोल्टेज प्रोवाइड करेंगे
So
तो
think. Time constant is equal to RC. You only told.
यस सर
I want to reduce the value of time constant. What can be done?
सर अगर हम बैंडविड्थ कम कर देंगे तो
Now observe the formula. Tau is equal to RC. You only told. I
यस
want
यस
to reduce that value. What is the possibility?
सर अगर हम फ्रीक्वेंसी इंक्रीज करेंगे तो हमारा टाइम कांस्टेंट जो है वो रिड्यूस हो सकता
Can
है
you give me the relationship between frequency and time constant?
सर टाइम कांस्टेंट का भी मैंने आरसी नेटवर्क के लिए फॉर्मूला आर इंटू सी बताया
Mm.
तो सी को अगर हम उसका ये इंडक्टिव सॉरी कैपेसिटिव रिएक्टेंस देखेंगे दैट इज एक्स सी उसका फॉर्मूला सर 1/2 2πfc हो सकता है, होता
Okay.
है।
Okay.
तो उस केस में टाइम कांस्टेंट जो है वो हमारा इनवर्सली प्रोपोर्शनल हो रहा है फ्रीक्वेंसी के। तो अगर हम फ्रीक्वेंसी इंक्रीज
Time
करेंगे।
constant is nowhere related with frequency. Tau is equal to simply RC. From where you got F? Time constant is going to depend upon only resistance and capacitance. Nowhere it is related with the frequency. If you decrease resistance, does time constant will not decrease?
डिक्रीज सर।
If you decrease capacitance, does time constant will not decrease?
It decreases sir।
In those two, which one is preferable practically? Decrement of resistance or decrement of capacitance or both?
सर डिक्रीमेंट ऑफ रेजिस्टेंस इज प्रेफरेबल,
Why
लॉसेस कम हो।
not? Why not decrement of capacitance?
सर रेजिस्टेंस डिक्रीज करेंगे तो हमारे पावर लॉसेस जो होते हैं, जो आई स्क्वायर आर लॉसेस होते हैं, वो रिड्यूस हो जाएंगे।
Okay, fine. So, is it possible to have a variable capacitor?
सर वेयर सर, वेरिएबल कैपेसिटर
Practically,
कब?
practically variable capacitor is possible.
ये सर वेरिएबल कैपेसिटर इज पॉसिबल।
So, which one easy to get, variable capacitor or variable resistance? Practically, getting variable resistance is possible or variable capacitance is possible. Yeah, both are practically possible. Which one is easy for us?
कैपेसिटेंस, वेरिएबल कैपेसिटेंस इज।
Okay. Okay, Pragatya, let me give you the feedback. Yeah, mostly you given correct answer, but see, time constant, if you want to decrease the time constant, just reduce the resistance.
ओके सर।
Okay. Variable capacitance is difficult. Why? Because C is equal to epsilon A by D.
यस सर, एरिया।
Okay, epsilon A by D. So that is very difficult. That's why we always go with resistance. And you given one answer that, sir, losses will decrease if I'm decreasing the resistance. So we are talking about electronic circuits. In electrical circuits, yes, resistance if you decrease, losses will be reduced. Here, instead of losses, see, electronic circuits itself deals with milliwatts of power, not with the watts even. Okay. Here, loss is not that important when compared to variable capacitance. Loss is also important in electronic circuits, but variable capacitance is difficult. Okay. Yeah, fine. For most of the questions, you given correct answer. Okay. And